what we'll do is we'll plot this and we'll see the variance plot, right? So again, the variance plot that you're looking here, the first singular value, or is capturing 68.93, principal component. Then the second principal component is capturing 16.51, and as I mentioned, the third one is capturing 9.38, and the fourth one is capturing 5.18%. So what we'll do is we will throw away the third and fourth, and we will just focus on 68.93, and we will basically focus on this two variants that we have, 68.93 and 61.5. These are the two dimensions that we'll capture, and then we will throw away the third and the fourth dimension, and that will help us in doing the dimensionality reduction from 4-dimensional data to a 2-dimensional data. Okay. So as you can see from the figure, that succeeding eigenvalues decrease in their values, and the principal components corresponding to the succeeding eigenvalues will capture lesser variance of the data. Okay. So now what we do is we will use this information and we will visualize the two principal component analysis data. So let's do that. So I'm running this code block, and here what we are doing is we are throwing away the third principal component dimension, the fourth principal component dimension, and we are just focusing on capturing the first two dimension. Okay, and we have done that, and that's the code block that I've executed. Now let's try to visualize this data set on a 2 dimensions. So what we have done now is we have created a plot where we have reduced the dimensionality of the iris data set from 4-dimension to 2-dimensional using principal component analysis. And now we can plot. So you can see U1 and U2 are the primary 2 dimensions, principal component dimensions that we are plotting this data set. And here the different colors, for example, the blue, gray, and the light blue, denotes different classes of iris flowers that we have. And as you can see, even if you are doing the dimensionality reduction and we have got this data, the class 1, the dark blue, is fairly different than the brown class and the light blue class that you can see. So as you can see, the data is informative enough. In fact, even if you have to do a classifier between the brown class and the light blue class that you see on this slide, we will be able to find a linear, most probably a good linear classifier, which will be able to partition this data. So looking visually into this data in 2-dimensional principal component that we have here, it could be ascertained that we have enough discriminative power in the data, and if you use a classifying algorithm, maybe we can use a linear classifier algorithm, and that might be good enough for classifying these three different classes. So this is how we have reduced the dimensionality from 4 dimensions to 2, but we can also visualize this data in a 3 dimension. But before we go that, one thing that I want to make a remark, that if we are visualizing these two principal components, these two principal components are essentially capturing 85.44% of the variance in the overall data, or that's the information that is typically there. So now let's move on and go to see how can we visualize this data in 3 dimensions. So what we are going to do now is we are going to now take the first 3 principal component axis, and we are going to retain those 3 components in the dimensionality reduction. So what we will do is we will reduce the dimensionality of the data from 4 to 3 using principal component analysis, and this dimensionality reduction has been carried out in a way that we will be using the first 3 principal component axis information. Okay, so that's what has been coded in this code block that you have. So we will be basically using the n component value equal to 3, and that's what we will be reducing the dimensionality to. Okay, so again, let's run this, and if you run this, right, we get this visualization. So this is the data that you can visualize in 3 dimensions that is there, right? So if you look into this data has a 3-dimensional axis, right, and you can see even from the data from the 3-dimensional axis by rotating and so on, that fairly the dark blue class is very easy class to recognize, and that has distinctly different from the red and the yellow class, which are the class 1 and class 2 categories. Okay, but even from this visualization you can ascertain that it might be easier to find a plane or a couple of planes that can easily separate the different classes of the data that we have, right? So this is one way to visualize and reduce the dimensionality of the data, and to check for different class of machine learning algorithm that you can apply on this data that is out there. Now when we have reduced this dimensionality from 4 to 3, the total number of variants or the total information capture is 94.82 because we are now taking into 3 different axes. So these 3 different axes combined together captures 94.8% of the overall variance in the data that is out there. Okay. So this is how we can also use the dimensionality reduction techniques like principal component analysis, and we can find out informative features. We can look into information whether the data is good enough, whether we will be able to do a linear classifier. If everything was jumbled up and mixed together, all the classes are mixed, probably linear classifier might not be the best one to use, and then that would have helped us in selecting a different class of classifier and so on. So this is an example of how dimensionality reduction, which is a class of unsupervised learning technique, helps you playing with just the input features and making some informed decision of what you want to do with that data. With that, I want to thank you for participating in this lecture and in fact for participating in this whole course. I really appreciate you taking this course, and at the same time I would like to highlight that we also offer other courses in the domain of data science, machine learning and AI, and we request and urge you to take those courses too. Thank you.